Hello everyone. Today we are going to discuss International Mathematical Olympiad Shortlisted Problem C6. I am the author of the problem. The problem selection committee members contributed a few beautiful solutions for the problem. I'm going to present one of them. Let n be a positive integer. Suppose we are given two endpoints in a plane such that no three of them are collinear. The points are to be labeled A1, A2, and A2n in some order. We can then connect them one by one in the order to form 2n angles. We need to prove that there exists an ordering of the given points such that the resulting 2n angles can be separated into two groups, with the sum of one group of angles equal to the sum of the other group. Let's take a look at an example of n equals 2. We have 4 points. This is the one of the correct labeling. Angle A1 plus angle A2 equals angle A3 plus angle A4. Another scenario, they can be connected like this. Angle A1 plus angle A2 plus angle A3 equals angle A4. To solve this problem, we have two jobs to do. First, we need to arrange the labeling, the order of the point. We also need to prove that such labeling will result in two angles that can be separated into two groups. So in the screen, you can see 8 points. So I already make the labeling. So I'm going to explain how did I do that. We first draw a line. This line separates the two endpoints into two parts. One side, there's two endpoints. There's one endpoint. The other side, another endpoint. And then on one side, I label them with odd number index, like A1, A3, A5, A7, and so on. On the other side, the even number index, A2, 4, 6, 8, and so on. So the order of the one side can be arbitrary. So you can switch like A1 and A3 and no problem at all. Then I connect the points based on the order from A1 to A2 to A3 to A4, A5, 6, 7, 8, and to A1. From a loop, we got two angles. Our next job is to show why this arrangement works. I draw another line connecting the two nodes A1 and A2. So this red line is going to rotate around each of the nodes. The first one is A2. Let's do that. Around A2, then A3, A4, A5, A6, A7, number 8, and finally A1. After the rotation, the red line go back to its original position. So the total rotation of the line can be 0 degree. It is possible it can be 180 or 360. We can see that during the rotation, the lines always connect one even index point and one odd index point. So in other words, the two sides of the line never cross over the separating lines. So in other words, the total rotation of the line is indeed 0. Which means that some of the rotations clockwise, some of the rotations counterclockwise, the clockwise rotations and the counterclockwise rotations cancel out. Let's try it again. A2 counterclockwise, clockwise, A3 clockwise, A4 is counterclockwise, clockwise, 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 clockwise. A8 is counterclockwise, and A1 counterclockwise. We have 3 angles. In this case, it's actually counterclockwise rotation. So that's A1, A8, and A4. So therefore, we establish the equality A1 plus A4 plus A8 equals the sum of the right angles. I have one exercise. Let n be a positive integer, and there are 2 endpoints in the plane such that every 3 of them are noncollinear. Using this point as vertices, 2n chose 3 triangles can be formed. Prove that these triangles can be separated into 2 groups with the sum of one group's triangle areas equal to the sum of the other. This is very similar to the problem we just discussed. Actually, I prepared several similar problems for them to consider. They chose that one. And actually, this one is my favorite. It looks easier than that one because so we don't have to decide the labeling. It's already there. And every triangle is included. Our only job is to do the separation of triangles. But actually, there are some additional hurdles for this problem. In my opinion, so this problem is more difficult than that one. Anyway, I give it to you to try. And this is all I have today. Thank you for your attention.